So we finished our conversation on Wednesday with a general discussion of, like what are fungi, what are molds, what are yeasts, difference between sexual, asexual spores, and so on. Now I want to say a few words about antifungal agents. And the main concern with trying to cure fungal infections is that fungi are eukaryotes, which makes it problematic because if we try to inhibit certain processes that belong to, fungal cellular metabolism, we run the risk of affecting the eukaryotic cells as well, like human cells. So however, there are some drugs that are specifically antifungal, but you have to appreciate that they have fairly high levels of side effects. So the first drug that comes to mind, the first group of drugs, and just as with antibacterial, I'm asking about the classes, not the names. So the first class are polyene drugs. Okay? So polyenes, they bind and disrupt the membrane. So this pretty interesting cyclic molecule is called amphotericin B. When you will come to clinic, if you will work with patients with infectious disease, that's the drug of choice for the treatment of fungal and protozoan diseases as well. Okay. Now, amphotericin B has pretty high levels of side effects, especially when it is administered IV, for patients with the systemic mycosis. I used amphotericin B in research practice. When you grow cells in culture, the first contaminant, like the scourge of cultured cells, is any kind of fungi, and we added amphotericin B to the medium to prevent the contamination. Cells were not very happy. It was sort of a last option to prevent them from being contaminated, but cells were not happy. They did not like amphotericin B. Griseofulvin, shown here, is the inhibitor of microtubule synthesis. So microtubule synthesis is a key step in the cell division. The centrioles consist of microtubules. So effectively preventing mitosis, griseofulvin has the fungistatic capacity, and then your immune system can take care of it. Flucytosine, shown here, is a modified version of the nitrogenous base cytosine. When it enters the fungal cells, it's metabolized to produce 5-fluorouracil, and then it is incorporated into the growing chain of DNA or RNA, inhibiting any further elongation of these molecules and essentially stopping DNA and RNA synthesis. But the most common drug that is used to treat fungal infections is the group of azole drugs. So those are broad spectrum and fairly safe and relatively low toxicity antifungal agents. They inhibit the synthesis of biological molecule ergosterol, polycyclic condensed molecule that is a component of fungal cell membrane. It's a key component of fungal cell membrane. And what's important, ergosterol is specific to fungal cells. So drugs like miconazole, ketoconazole, fluconazole are among the most popular antifungal drugs. For instance, they are prescribed for the oral administration in case of thrush or candidiasis. Make sense? So these four groups, polyene drugs, griseofulvin, flucytosine, and azole drugs, I want you to know. And with this, we are moving to fungal diseases. before we actually will start talking about any specific diseases, I want to highlight a very interesting feature of fungal infections. Fungal infections in otherwise healthy and immunocompetent hosts are extremely rare. Does that make sense? Do you understand what I'm saying? So for people like us, like healthy adults, getting a systemic mycosis or mycosis that goes beyond the skin is extremely rare. The reasons behind it are pretty unclear, but famous microbiologist who's alive now, Arturo Casadevall, he proposes that the inability of fungi to infect healthy people lies in the temperature difference between the human body and the environment. Fungi usually grow at a pretty ambient temperature, so we're talking about 70s Fahrenheit, right? And when it gets to the human body, we're talking about 100 Fahrenheit. So that's pretty significant difference. And if you would look at the diseases that we're going to discuss, virtually all of them affect people who are immunocompromised. Okay? So basically, fungus has to deal with two bad things, according to Casadevall. One is high temperature, second is immunity. High temperature and fully functional immunity puts a complete brake on fungal replication. But if immunity is virtually gone, it can kind of survive in that elevated temperature of the human body. That's the idea. Does that make sense? So, the first type of mycosis are cutaneous ones, the ones that affect skin. The group of 3 microorganisms here, Trichophyton, Epidermophyton, and Microsporum, these 3 genera, they all can cause the disease that is commonly known as the ringworm. Okay, more fancy name for it is tinea something. Tinea stands for worm, and then something is a part of the body where this cutaneous mycosis can be found. For instance, tinea corporis is the mycosis of the body. Tinea pedis is known as the athlete's foot. Tinea barbae is found on the face. Okay. Now there are more different tineas. If you know this 3 corporis, barbae, and tinea pedis, it's fine with me. I really want you to focus on knowing these 3 genera. So if I ask you, sort of which of the following microorganisms causes exclusively cutaneous mycosis, you pick one of these 3. Are we clear? That make sense? Good. Now, aspergillosis. By the way, this is how trichophyton growth is seen on the suborder agar. Okay. I don't think we ever isolated trichophyton from the environment here in this class. Now, aspergillus, usually a secondary infection. Here, you see a pretty bad case of cutaneous aspergillosis on the leg of a patient. Usually, that results from the systemic spread of aspergillus. That starts as the respiratory infection, enters the bloodstream, and appears as the cutaneous infection some other side. That is a great example of a focal infection. Remember, we talked about localized versus focal. Aspergillus can be commonly found in the environment. It can grow as the mold in the environment, like in the damp, warm places. If I don't know, the basement is frequently flooded. It loves to grow in the woods, wood chips, and so on and so forth. Okay. Candida. So this is Candida albicans growing on the subaortic agar. And this is the cutaneous candidiasis and Candida albicans on the nails. So this is fairly infrequent. This is pretty frequent. Candidiasis of the nails. You also know this disease is the infection of the mucosal membranes. When Candida albicans grows on the mucosal membranes of the throat, we call it thrush. When it grows on the mucosal membrane of the vagina, it's candidiasis or Candida vaginosis. Okay. Usually both thrush and candidiasis arise from antibiotic treatment, like heavy antibiotic treatment. And often if you are prescribed a broad spectrum antibiotics for some kind of infection, say, I don't know, advanced urinary tract infection, you get your antibiotics in a pretty high dose. Your physician may also prescribe ketoconazole to prevent, because Candida albicans can be normally present in the respiratory microbiome or in the vaginal microbiome. But when composition of the microbiome is changed, Candida albicans starts to proliferate much faster than usual. Does that make sense? Now, all these conditions can be fairly easily treated. We have a lot of drugs, azole-based, gizofalvin-based. It's perfectly fine. One of the greatest stories about the treatment of athlete's foot comes from a great musician and the great doctor called Ozzy Osbourne. If you haven't read his book called Trust Me, I'm Dr. Ozzy, I strongly recommend this book. It's a wonderful medical encyclopedia where his fans ask medical advice. And one of the questions is, Dear Ozzy, during tours, you probably had athlete's foot because, it's damp and hot and whatnot. So what did you do about it? And he said, in the time when we were touring with Black Sabbath, cocaine was heavily mixed with antifungals, like the powder that was used to treat athlete's foot. So we just used the same stuff that we snorted to apply it to our feet. And it worked great with only one disadvantage. Each foot was about $1,000. So, but speaking seriously, great book. Get it. Anyway, we going forward to, systemic mycosis of internal organs. So the first that we're going to talk about is Cryptococcus neoformans. So these are cryptococcal cells. They have very characteristic appearance. Okay? As virtually any other systemic mycosis, cryptococcal infection starts as the respiratory one. Upon the inhalation of fungal spores, Cryptococcus starts to grow as the yeast in the lungs, then spreading systemically and reaching the brain. And after this gradual onset, it leads to chronic meningitis, which is characterized by the headache and the typical symptom of virtually all meningitis, stiff neck. Cryptococcus neoformans infection is the hallmark infection of AIDS patients. Now, I mentioned the characteristic appearance of these cells. If you would look at them, you'll notice a pretty significant capsule that surrounds each cell. So that's one of the virulence factors that makes this microorganism fairly resistant to phagocytosis. Transmission route for Cryptococcus neoformans is zoonotic. You can acquire it from aerosolized birds droppings or bat droppings, it's treatable. But the main problem with treating any fungal, any eukaryotic infection in immunocompromised patients is that the majority of drugs are not fungicidal, they're fungistatic. They prevent usually the division of or growth of fungi and leave the clearance of fungal infection for the immune system. And in AIDS patients, the immune system is virtually gone, so it becomes a bit of a problem. Okay. Another microorganism that causes neurological disease is Coccidioides immitis, also called valley fever. So here you can see asexual spores of Coccidioides immitis living in microconidia. This is the cutaneous manifestations, but I want to highlight again, it can manifest cutaneously. It can manifest itself in the skin. But here we're focusing on something more serious. Okay, so Coccidioides can cause neurotropic disease. And meningitis, if untreated, is fatal, 100%. This is the distribution of Coccidioides immitis in the United States and Mexico. You can see that it's very much endemic. It's present in a very specific region, okay, in Southwest. The interesting feature of Coccidioides immitis is that it's very, very contagious, extremely contagious. And due to this contagiousness, it was a BSL-3 agent and was classified as the select agent. Now, I don't remember if I used this expression, the select agent. That's the classification provided by USDA, interestingly enough, United States Department of Agriculture. They classify agents as select agents if they can be used as the potential biological warfare, meaning that they are technically suitable. So say Bacillus anthracis, causative agent of anthrax, is the select agent. Coccidioides immitis is the select agent, but yellow fever is not, because it can be hardly spread via respiratory route, for instance. Does that make sense? And the government restrictions on working with select agents are pretty severe. For instance, all samples, if you work with a select agent, all samples must be accounted for. Which means if you have one vial of, suspension of Coccidioides immitis, you have a number, you have all the characteristics, everything's written, you know exactly where it is in the freezer, and you have it in the catalog. If you take this vial and split it in 4, you add records in the catalog with all the numbers and location and everything. And in about 2000, I want to say 2009-10, I want to say, USDA changed the rules and said that all animals that were ever infected with a select agent and all organs that are collected from those animals, even if they are untested, all those organs automatically become select agents. And it created a massive outcry among researchers, because imagine you have, 100 mice, and you collect 10 organs from each mouse, and you never label them like a select agent, you just have those in the boxes. Well, realistically speaking, researchers have tens of thousands of organ samples from all those infected mice stored in the freezers. And when this law was adopted, my former bosses, they realized the amount of work that they will have to do to catalog all those organs, because you cannot move select agents across the border. It's the felony. I mean, you can, but you got to have a permission. Everything has to be cataloged and so on and so forth. They said, we're not going to catalog it. We'll just autoclave it. So it created a huge amount of problems. And by the way, for violation of those policies, you go to jail. It's not misdemeanor. It's a felony. Because it's considered like you let the biowarfare out. Now, here I want to focus on some respiratory infections caused by fungi. The first one, Mycoses jirovecii. Those cells cause hallmark infection of AIDS patients. So if Cryptococcus neoformans causes a hallmark cryptococcal meningitis, Mycoses jirovecii causes fungal pneumonia, also known as PCP, Mycoses carinii pneumonia. You may ask, hold on, why Mycoses carinii? Because apparently, for some reason, taxonomists were not happy with the name Mycoses carinii and renamed it to Mycoses jirovecii. It's the same, absolutely the same fungus, just they changed the name of it. Respiratory transmitted from the environment, fever, trouble breathing, cough, shortness of breath, immune staining of the sputum, chest x-ray for diagnostics. So patients who are severely immunocompromised should take prophylactic TMP-SMX Bactrim. Turns out trimethoprim sulfamethoxazole is not only antibacterial, so it can be antifungal. It can be treated. Now, Aspergillus is something that is largely underestimated in terms of its danger. It's the mold. Again, it's the mold that can be found in the general environment. And if those spores of Aspergillus end up in the lungs of immunocompromised patients, they will start to grow in the immunocompromised patients as the mold. So imagine the growth of the so-called fungal ball in the lungs. Does that make sense? So you have a mycelium growing in the lungs. And yeah, it has been known for quite a while about this type of respiratory infection from Aspergillus. It was actually, originally the lung infection with Aspergillus was discovered in turkeys. It's quite an interesting story. Wild turkeys, I believe it was somewhere in Austria, were found dead along the railroad tracks. And there were like a lot of them. So biologists dissected them and found that they had Aspergillus growth in the lungs, completely occupying the whole space in the lungs. So they practically suffocated. They started to look at, where could they get Aspergillus, and it turned out that they were feeding off the scraps that passengers of the trains were throwing onto the gravel next to the railroad tracks. And those scraps provided a rich growth medium for Aspergillus. So they were basically eating the mold, and that mold got transmitted into their lungs, and they had this growth and they died. And later the same story with a pulmonary aspergillosis was found in humans. Now, blastomyces dermatitis is causative agent for blastomycosis. There's a cutaneous and the respiratory form. So that's the fungal cells in the lungs. In people who are healthy, it's usually self-limiting. It's usually self-limited to the cutaneous one. Although you can see that in immunocompromised like this patient, blastomycosis can lead to disfiguring, damage of the skin. Okay. Now, that basically concludes the story about bacteria and fungi, but I wanted to mention one more fungus, which is kind of sort of a funny story. Have you heard about the fungus called ergot? So it's not, I wouldn't say that it's a human pathogen, but it's the fungus that first and foremost affects crops, specifically wheat and rye. It grows on the stems, where the grains are, and negatively affects the growth of those crops. That makes sense. It's like, like the fungus, like those mushrooms that grow on the trees, same type of deal, but it's much smaller. It was a pretty significant problem during the medieval times. And here's why that was the problem. When people collected that grain and they brought it to the mill and they milled it into the flour and they used that flour to, bake the bread, soon after they baked the bread and they ate the bread, they became psychotic. Like people were jumping out of the windows, behaved terribly weirdly, all kinds of, weird behaviors. That makes sense? And they were thought, it's medieval times, they were thought to be possessed by Satan. And you know what kind of strengthened that idea? When people got the flour from monks, from, local churches, their bread was fine. Monastery bread was totally fine. Or the flour was totally fine. So it kind of strengthened, if you get, like, God-blessed bread, it's healthy. If you do it yourself, you're going to get possessed by Satan. Later, it was explained, and it was explained in a super elegant way. Turns out, ergot contains psychedelic compounds, which basically give people bad trips. Like LSD, but bad trips. So they were hallucinating and jumping out of the windows and whatnot. You have to understand that those churches and monasteries, they were growing that same stuff. So grain had ergot as well. But they had grain stored for 1-2 years in like the basement. And over that time, the psychedelic compounds got all disintegrated. So yeah, it still had all the ergot contamination, but it was not really contamination. Chemicals were gone. Okay? So all you need to do is to store it for a year or two. That worked. By the way, there are some people who kind of hunt, try to collect the ergot, because you can isolate it. You can make your own kind of LSD, yes.
If you ate, like, that bread, how long would the, trip last, or would it be, for good?
As far as I know, it was very transient. I mean, you eat it, you have, a couple of hours, maybe, whatever shape, and then it goes away. But remember, all the bread that is produced from your own flour, or, generally not church-produced flour, would contain this. So it's kind of hard life to lead when you eat the bread and you don't know if you're going to have a trip or not. So that was kind of an interesting story.